Welcome to the demo. We'll guide you through deploying a custom Windows VM image to an edge node using EMT-S, starting with creating a bootable USB on an Intel-based machine. We begin by visiting the official open-source GitHub repository, where the toolkit is freely available. From there, we download it to a standard laptop or development system. To generate the installation package, we run a straightforward command sudo make build, as you can see here. This command compiles all the necessary files into a single compressed archive conveniently located in the installer output directory. In our testing, we are using Raptor Lake 13th Gen Intel Core i5 platform. The toolkit includes an automated installer that simplifies the creation of a bootable USB drive, a key step in deploying your edge environment. Once the installer is downloaded, we extract its contents just like unzipping a folder. Inside, we find everything needed to prepare the bootable USB drive. With the USB setup nearly complete, the next step is to prepare the application components that will run on the edge node. To download them, we execute the download images script, as shown here. These artifacts are automatically transferred to the persistent volume on the edge node under the opt user apps directory during installation. These include Kubernetes artifacts, such as container images and manifest files, which are essential for launching and managing applications. The installer package also includes a user apps folder in its root directory. This serves as a placeholder where users can place their own application files, such as container images, Helm charts, or custom VM images. This will pull in the additional components required for virtualization features. As you can see, we've copied the Helm charts and a custom Windows VM image into the user apps folder. Next, we are copying the config file into installer root directory. We refer to the Cloud-Init configuration to update the config file. This step allows us to define essential settings such as user credentials, network and proxy configuration, and any services we want to start during the initial boot. This approach provides the flexibility to control how artifacts are deployed and managed, both during and after installation. Once both the bootable USB and the application stack are ready, we are fully prepared to install the environment onto the edge device, bringing up a reliable, customizable, and production-ready edge node with minimal effort. With the updated image and configuration in place, we use the installer to create a final bootable USB drive, as you can see the progress of final preparation script to create the bootable USB. Now the final bootable USB is ready. A custom image can be copied locally from your development system to the fifth partition of the bootable USB drive, as shown here. By default, the Edge Microvisor Toolkit, EMT, image resides in this fifth partition. Remove the existing EMT raw image and replace it with custom image such as the EMT DV image. Once the replacement is complete, unmount the partition to ensure all changes are safely written, as you can see here. Once unmount, the new custom image is on the right partition. Finally, unplug the attached bootable USB drive from the developer system and plug into the edge node. Now, let's walk through the deployment process on the edge node. First, the customer takes the prepared bootable USB stick and inserts it into the edge node device. Using the BIOS or boot menu, they select USB as the primary boot option. This ensures the edge node will start up directly from a USB drive. As the system begins to boot, the automated installer for the Edge Microvisor Toolkit is launched. On the screen, you'll see the Microvisor installation progress, which may take a few minutes to complete depending on system specifications. Once the installation reaches completion, the edge node will automatically reboot. On its very first boot, Cloud-Init will install the K3s Kubernetes cluster, enabling robust container orchestration on the edge device. Following the Kubernetes setup, the system proceeds with the deployment of the custom Windows application as a virtual machine. As you can see, Windows VM deployment is completed and Windows VM launched. We can now run the kubectl command to verify the pod services running on Windows VM. In this part of the demo, we focus on validating the deployed environment using the WebGL Aquarium benchmark. After deploying the custom Windows application as a virtual machine on the edge node, it's essential to confirm that the system's graphics capabilities are functioning as expected. For this purpose, we use the WebGL Aquarium benchmark, a widely recognized tool for measuring browser-based graphics performance. The process begins by launching the WebGL Aquarium application within the Windows VM environment. This benchmark simulates hundreds or thousands of animated fish, leveraging the power of WebGL to render complex graphics directly inside a browser window. As the benchmark runs, It provides real-time feedback on metrics such as frame rate, rendering quality, and GPU utilization. By observing these results, we can quickly assess the edge node's ability to handle graphics-intensive workloads. To further assess resource utilization, we also compare the system's RAM usage before and after running the test. This provides insight into the efficiency and readiness of the Windows VM environment on the edge node, confirming that it can handle real-world workloads smoothly. Thanks for watching the demo.